to use this fixture in these helper methods, and I'm gonna do whatever it takes to make it happen. Welcome to the Python Halloween special. It's that time of year when we go around looking for a little mischief. In this video, we'll bend a few rules and venture into areas of the language most people fear to tread. Along the way, you'll learn a few tricks and see a few treats. So sit forward and pay attention, because we're about to begin. The target in today's video is, in my opinion, the best testing framework in Python, Pytest. We'll specifically be exploiting a few techniques in order to overcome an intentional limitation in Pytest. I will most likely be in trouble with the maintainers after this, but hey, it's Halloween. One of the most useful features of Pytest is fixtures. Fixtures are functions that are commonly used for test setup and teardown. They're easily passed around among other fixtures and tests, but not in other places. Let's take a look at our Halloween app to see what I mean. Here we have a basic Halloween app that we've been developing, and on the left you can see there's really not much to it. We also have a few helper methods that our main app uses, and on the right you can see we have a couple of tests for our app as well. These tests, like the app itself, are pretty basic. However, what we're interested in here is this fixture that's defined, the fixture called Session Killer. It is a session scope fixture that simply yields a killer. This fixture, Session Killer, is used in both of the tests, which you can see in the function call signature. It could also be used in another fixture. What we're interested in is being able to use this session killer fixture in our test helpers file, meaning I would like us to be able to use session killer just like we would in a test or another fixture, meaning I would like for us to use session killer in these helper functions much like we would in a fixture or in other tests. However, this isn't something that's currently possible. It's something you could get around relatively easy before, but has since been removed since Pytest 4. The maintainers, likely rightfully so, decided that fixture use should remain within the Pytest framework. But it's Halloween, and that's not good enough for me. I want to use this fixture in these helper methods, and I'm gonna do whatever it takes to make it happen. So how do we do this? First, let's show you what happens if we try to run these tests. First, let's show you what happens if we try to run these tests in their current state. Ooh, we get a nasty failure. We see we have a type error that our helper function, getWorstKiller, is missing a required positional argument, session killer, because it's not being passed along by Pytest. So let's begin our investigation here. We know that test winning message is getting session killer passed in, because if we were to put in a breakpoint and then debug this test, we get into the debug console and we can see that session killer has a value of Michael Myers. So something that happens before this is populating session killer. Let's add some statements here. Let's import inspect, because we want to pull the current stack at this point. What this does is it gives us all the frames that have led up to the point where we call inspect.stack. So let's debug this again. Now we're in the debug session. Let's look at the value of stack. We see we have a list of frames. These are frames starting at where we're currently at, heading back up the call chain to the very top level. We're likely going to be interested in something that is close to the bottom. Here we see the code context is where we actually called inspect.stack here. So let's go up another frame. Here we go. we can see that the code context isn't part of our code. And we can see the file that this is running from. We see that we're now within the Pytest framework. If we open this file up and specifically go down to the line number that it's calling out, 183, we can now see what Pytest is doing. It's calling our test, the test function itself, and passing in a dictionary of test arguments. Those test arguments are constructed in the dictionary comprehension that happens on line 182. With some context clues, we can assume that pyfuncItem is one of our test functions, and that they've added a private attribute called fixture_info, and as part of fixture_info, we have arg names associated with that. Well, let's take a look around this file and see if we can figure out where this private attribute fixture_info is added. And here, down around line 1609, we see that fixture_info is generated from a method of a private object called fixture_manager. Now that's interesting. That means that Pytest is using some kind of fixture_manager object to maintain the information that we need. So, since Pytest is an open source project, we can continue our investigation of this fixture_manager class in GitHub. And here we are on the Pytest GitHub page. Let's do a search fixture_manager in here and see if we can figure out where this is defined. Oh, looks like we don't need to go far. We see that fixture_manager class is provided by _pytest.fixtures. And when we go to that file, we see that indeed on line 1395, we begin the class definition for the fixture_manager. And its description tells us fixture definitions and information is stored and managed from this class. Now, if we take a look through this class, we see there's a lot of reference to nodes. Now, that's not something that we really want to be passing around from our helper methods, so we may not have an incredibly convenient way of getting what we want. However, up at the top in the init, I did notice something interesting. We have a reference to self.arg to fixture defs, which is a dictionary. This could be what we're looking for. Now let's head back into VS Code and see what we can figure out. So, we know that Pytest is using a fixture_manager to store the information about our fixtures that we care about. And they want to hide that information from us. But this is Python. And if there's an object alive, there's a way to get a reference to it. Why don't we use something that is commonly associated with the life and death of objects? And that is Python's garbage collector. You see, Python's garbage collector stores a reference to all the objects that it's tracking. And I'm betting that since Pytest is running currently, we can find our fixture_manager in those objects. The garbage collector exposes some convenient methods for us. The one that I'm interested in right now is getObjects. If we were to run this, we'll see we'd get a lot of information. These are all different objects that are currently alive in Python right now. Too many to show on the screen. However, it does give us a length here at the bottom, 45,591. So we're going to have to come up with a way to pick our fixture_manager out of those. Well, we've already seen Pytest itself import that fixture_manager class, so let's do the same. Okay, we now have a reference to the fixture_manager class. We can use this as a basis for a list comprehension to pull out all instances of fixture_managers that are currently tracked by the garbage collector. Since I'm betting this is a singleton, we should likely just get one. But let's see what we get from it. We run it, and we see that, yes, indeed, we have a single object in here, and that is a Pytest fixture manager object. And would you look at that? We've got some attributes under there as well, including what exactly we were looking for. This arg to fixture defs dictionary. So let's see what this contains. I see by looking at these names, these are some of the built-in fixtures that are provided by Pytest. A lot of these are extremely helpful. But if we look at the bottom, we see session killer. Interesting. And it has a single entry. So there's one value for session killer. And that value is a fixture def. If we look on here, we can see some information about it, about its base ID. And then, oh, look here. We have a cached result. And that cached result has Freddy Krueger in it. So it looks like we found our way in. We can use the garbage collector to steal a reference to Pytest fixture manager instance. And then from that, we can look in its private arg to fixtures def dictionary and then find the fixture that we want. And then from there, look in its cache results and get the value that we want out of it. Okay, now that we have that information, I'll put together a prototype and bring you back when I'm done. Okay, so I think we have it. I wrote a new class called Fixture Finder, which uses a combination of techniques to do what I want it to do. The first is what you've already seen, is how I steal the fixture manager object from Python's garbage collector. And if I'm unable to find it, that means that someone's trying to use the fixture manager outside of when Pytest is running. So we simply raise an exception, telling them that they shouldn't do that. Next, we have some helper methods. One is to simply find a fixture value from the arg to fixtures def dictionary, going into the fixture name, and then checking the cache result, and then returning the first item in that cache result. Then we have a method that can be called within a function that will look for the names within that function's arg spec and see if it matches any of the names of fixtures. If so, then it'll replace the value of that variable locally with the value of that cache result. And then finally, and maybe the simplest use, is a decorator called useFixtures. If you have this decorator, then it will automatically resolve the fixture values in a manner most similar to what Pytest does itself. So let's try these out. First thing is to import the pre-made instance of a fixture finder. So from myapp.import fixture finder. And now we'll get rid of the session killer reference here, because the first method that we're going to use is find fixture val. So we'll say session killer is equal to fixture finder dot find fixture val and pass in session killer. Now, since this is an app, we'll just reinstall it, and then we'll debug the test that uses that method. And if we look at the value for session killer, we see that is equal to pinhead, which we can see below. Beautiful. So it looks like our find fixture val method worked perfectly. And if we continue the test, we see that it indeed passed. So let's look at those other methods for resolving the fixture. Let's try resolve fixtures next. This time we're going to get a bit closer to what we would see within Pytest. So we'll say session killer is equal to none. And then instead of find fixture val, we'll say resolve fixtures. We still have to have the equals none here, because if we don't, then we'd just be calling the method without a required positional argument. And when we modify that to resolve fixtures, go back and run our test, we see that it also passed. Finally, the last version is the version that is closest to Pytest. We get rid of the equals none, we get rid of resolve fixtures, Instead, decorate this with fixture finder.useFixtures. Save that, reinstall our app, go back, run our test, and it again passes. If we debug our test, we can see that the method runs. Session killer has the value of Ghostface, which is the same as what we saw with our test. Beautiful. Okay, so now we have a way to easily reuse fixture values outside of direct fixture use and test use through Pytest. As long as we're in a Pytest session, we can use the same values of these fixtures as our fixtures and tests can. Well, that wraps up this year's Halloween special. As you can see, we got into quite a bit of mischief, and more importantly, dug into some lesser known parts of Python to achieve our goal. I will be doing videos in the future around inspect and a small series on Pytest. The source code for this video will be available on the Understanding GitHub repo. If you have any questions or suggestions for next year's special, please leave a comment down below. Until next time, thanks for watching, and stay spooky.